Hi, my name is Kristin Wortman from APL also, and what I'm going to talk about today is based on an experience, a recent experience from the RBSP mission in software requirements verification. Hence the presentation is named Striving for Reuse and Independent Requirements Verification of Command and Data Handling Flight Software. A few things that I'm going to talk about. First, I want to set the context for our independent requirements verification. We also refer to it as our independent software acceptance testing. I want to give you an overview of APL's unmanned spacecraft software system test structure, and then talk a little bit about the attributes of the command and data handling flight software that we use for RBSP, and talk a little bit about the process which we followed for independent requirements verification and the organization of our documentation, our requirements documentation, and our test specifications. And then I'm going to pull out an example of one of our RBSP test designs and discuss how we can reuse it and what the potential is for our reuse, and also what mission dependencies we have in our test designs at this point, and the plan for test reuse on future APL supported missions. We have Solar Probe Plus coming up, and that's one of the target missions that we're going to use it. So the software test structure that we use is basically a four-layered test structure, and the first three layers, the unit, the system, and the acceptance testing, is all part of our software development process. At the acceptance test level, we basically follow a black box approach, and the test cases are designed and conducted by independent test engineers. That by independent we mean they were not involved with the actual development of the functionality which they're going to test. We also run all our tests in a test bed or a test simulation environment, and our process is pretty much formal. We document our test cases, we peer review them, and we also have software quality assurance involved. I already discussed the first three bullets, so I'm going to jump right down to the documentation that we use. Our requirements and our test specifications are all maintained, developed in DOORS, our requirements management system. And if you're familiar with DOORS, it allows us to link our actual test cases to the flight software requirements specification. I think in an earlier discussion, they were talking about requirements traceability, and this is where we get our traceability. Our goal is to achieve a high confidence level in our flight software before we release it to the users, the integration and test team, and the mission operations team. A little bit about the RBSP command and data handling flight software. We consider it a critical CSCI. Therefore, our Space Department process requires that we perform an independent requirements verification. The functionality is actually implemented in 17 APL developed applications, and it works with the Goddard's Core Flight Executive Architecture. For RBSP, there were 421 total functional requirements that needed to be verified. A little bit about our acceptance test process. The flight software lead and our mission software systems engineer established a criticality rating and a verification method attribute for each one of our software requirements. And using this information, we took two different approaches to testing the actual requirements. One was we wrote functional test cases. These are your basic positive and negative type testing, and they were used to verify our most critical requirements. And basically the test steps are predetermined and peer-reviewed and scripted, and it's a repeatable test. The second type we used was an exploratory test, which was basically a session-based test where we took some of the lesser critical requirements which didn't naturally fit into some of our functional test cases. And for these, the test steps really evolved during the session following a charter which was written from the requirements to be tested. There was virtually no scripts, and it really was not a repeatable test. Now, this breaks down the 17 applications which we developed for our flight software and the number of requirements for each type of the application and the number of functional test cases and the number of exploratory test cases which we used. The red color shows the potential for the reuse in the application and in the functional test cases. And you can tell from this there's approximately 70%, 70 to 75% if you add up the numbers, that we could get reuse in our flight software and also in the test cases. Now, I wanted to show the organization of our flight software requirements and our test specifications. The flight software requirement specification on the left has the requirements broken down by functional area, and the test specification is basically following the same kind of organization, only we have our functional and our exploratory test. Another thing to note about our test specifications is section 2, which we call common test setups, operations, test tools, and procedures. And in this section, we basically put all the specific test environment procedures and test tools that we need to use for our test bed. These are very mission specific, but how we wrote our test cases is we just refer to the section 2. And so when we go to use it for reuse, we can actually replace the section 2. And we'll talk about that in a minute. I pulled out one example of a test case. I took the simple one of command ingest. The requirements are on the left, and we had a set of functional test cases which map to them. Now, we use the CCSDS telecommand protocol, and I just put this picture up there just in case somebody wasn't familiar with it. This test case actually the blue part is the transfer layer, and it basically tests the transfer frame header and the data field. Now, this is a snapshot of doors, and if you're familiar with doors, it's object-based, and each object has an object header. But one of the things that we didn't do in acceptance test previously is we did not make use of the object headers. We just wrote all our test steps in the actual object itself. So when you looked at this view, you didn't actually get this high-level, short, cryptic description of the steps necessary to actually run the test or to write the test script that goes with it. So that's something that we did different on RBSP, which I think is going to help us a lot when we move on to our missions like Solar Pro Plus. Again, the test environment is rolled up into a separate step. You can also, basically it's just poking in some invalid values into some of the header fields and poking around with the length of the transfer frame data fields and just sending valid commands. Now, this was a special test case in that we had to use the test bed software in order to generate our actual commands. We cannot send an invalid command through our ground system because it's going to do the validity checks and kick the command out before it even gets to the flight software. So this bypasses the ground system, and we have a tool that allows us to go in and poke the individual values and create our commands. So we have some mission dependencies. We're now looking at the RBSP test cases, and we have found that we have a lot of mission dependencies in our test design, even though we have some high-level reuse. One of the problem areas is the mnemonics for our missions, for our command and telemetry definitions. They're unique to our missions. So our test steps, the actual high-level test step that you saw, the details of those contain these actual mnemonic names. So that portion of it is going to be difficult to reuse. We're going to have to go in and virtually replace all the mnemonic names. We ran into this problem with our test scripts when we were trying to go back and do regression. The databases were swapped in, the mnemonics conventions were still being established. So what we had to do there is we wrote a tool that actually went in and found and replaced all the mnemonics in our test scripts so that we could run our regression without too much manual labor, but we still had the problem where our test design and our documentation still had the old names. Another area is our test environment. It is always unique to our missions. They have a different set of tools. In the case of the command ingest example, our valid and invalid command files, which we generated with this tool and we used as test inputs, it basically generates a script in the command language of our RBSP testbed. So when we move to another mission, we're going to have something that's comparable to that because we'll have to go back and remake all our test inputs following our test designs. Another dependency that we have is all our scripts, all our test designs were implemented in a scripting language which is supported by our RBSP ground system. We're using the L3 in control system. So we can't, unless the next missions are using L3, we wouldn't be able to directly reuse the scripts. We'd have to rewrite the entire scripts. And there's also some specific fields in the CCSDS protocol which are mission dependent. So where do we get the reuse? Well, if we go back to the test specifications, I mentioned that there was a section 2 which rolled up all our tools in our test environment, and each one of our test cases actually calls or refers back to those procedures in order to use the test bed, set up the ground system, set up the test bed software, use the actual tools. This can easily be replaced. We can go in and just replace that section so we still have, we have everything unique for the mission that we need. The rolled up version of the doors where I showed the object headers, we can use that test design. It's the basic, you're going to do 1, 2, 3, 4, and 5. Now the actual details which are contained within those test steps will require some minor changes. We used a nomenclature for all our command inputs, our test inputs, our artifact files, and all our scripts. Everything is unique to an RBSP test identifier. We can also reuse the test scripts, like I mentioned, if the ground system is the same as RBSP. If we use in control, we will have to use the find and replace command and telemetry mnemonic script that we wrote and just change the environment setup procedure calls. So what is our plan for reuse on the future missions? Well, we have 2 missions that APL will be supporting over the next few years, and one is Solar Probe Plus. Both of them will be using CFE architecture, and right now they're looking at all the reuse of the common applications, which they're actually calling their core, which they're going to move forward into both of these missions. And from the acceptance test or requirements verification perspective, we're looking at the actual test cases that verify those requirements, and we plan to reuse as much as possible. And we can, Solar Probe Plus is using the in-control ground system, so we can also get some reuse out of our test scripts. The same holds true for another mission we have, which is Precision Tracking in Space System. The only thing there is they are using a different ground system, and so that means that we will have to rewrite all the test scripts. So what were the lessons learned from RBSP? Well, first thing is we probably should not have hard-coded in our documentation all the specific command and telemetry mnemonics. As we move forward, we're going to just use descriptions. We're just going to say a command to do blah blah instead of a specific command name, and that'll help make our test designs more reusable for the future. And something that we did right was we did follow some conventions when we wrote our scripts in regards to rolling up the test environment, the procedure calls, because we can just simply go in and replace those, set up test bed, and whatever test bed we're using, hopefully, that'll just set it up, or whatever ground system requirement, if you need to use COP1 or whatever, you can just call that procedure to set up COP1. So from that perspective, we did pretty well. Another lesson that we learned kind of late in the process was automate as much as possible the verification steps. We had a lot of manual verification, things like looking at CFE events to make sure that they had been generated when we encountered certain errors. We later on automated that, and we also started putting all our test scripts and combining them into a comprehensive test suite following a test framework. This is something that we need to do for Solar Probe and for PTSS, is we need to use the test framework from the very beginning rather than coming in late and trying to go back and change and add some wrappers around our test scripts and make a comprehensive regression test suite combining the system test and the requirements verification test. Well, that was pretty much all I had.
Are there questions? No? Okay, very good. Thank you very much.
Thank you.